Hey everyone, welcome back to the College Algebra playlist. In the previous video, we took a look at complex numbers. Alright, we showed what they are, how to visualize them on the complex plane, and how to add and subtract them. Alright, in this video, we're going to learn how to multiply and divide complex numbers. Alright, so let's dive into it. Okay, here we go. Multiplying complex numbers. Let's have a brief recap of everything we learned in the previous video. Alright, we define the imaginary number I as the square root of negative 1, where we have I squared equals negative 1. Okay, so if we square both sides of this equation here, we get this important result. Alright, we're going to use this result a lot in this video, so remember that I squared equals negative 1. Okay? A complex number, written in standard form, is given as a plus bi, where a is called the real part and b is called the imaginary part. Alright, so a complex number is the sum of a real number and an imaginary number. Okay? We can visualize complex numbers by plotting points in the complex plane. Alright, so the complex plane looks pretty similar to the standard Cartesian coordinate system, right? On the horizontal axis, we have the real part, and then on the vertical axis, we have the imaginary part. Okay? And finally, to add or subtract complex numbers, combine the real parts, then combine the imaginary parts. Okay? So these two formulas show us how we can add and subtract complex numbers. Alright? So now we're ready to enter the multiplication realm. Alright, let's try to multiply these two complex numbers. We have 4 plus 3i times 2 minus 5i. And what this looks like is the product of two binomials. Alright, we know how to multiply two binomials, right? We just use FOIL to get rid of the parentheses. Alright, so we're going to FOIL this right now. Alright, for the firsts, in blue, we have 4 times 2. Okay, and then for the outers in red, we have 4 times negative 5i. And for the inners in green, we have 3i times 2. And then for the lasts in purple, we have 3i times negative 5i. Okay? So remember, FOIL is when you add up those four products. Okay? So we can clean up this business in the parentheses a little bit. All right? We have 8 plus negative 20i, all right, plus 6i, plus 3 times negative 5 is negative 15, and then I times I is I squared. Okay? So next, we can get rid of these unnecessary parentheses here, right? We have 8 minus 20i plus 6i plus negative 15 times negative 1. Okay, we're replacing this I squared with negative 1. All right? And that gives us 8 plus 15, all right, minus 20i plus 6i. And we get 23 minus 14i. Okay, remember, you can add these imaginary numbers essentially like they're like terms. Okay? So this is our final answer. Let's try one more. All right? Once again, we're going to FOIL this. All right? So the firsts, we have 3 times 2. Okay? And for the outers, we have 3 times 3i. And for the inners, we have 4i times 2. And then for the lasts, we have 4i times 3i. All right? So we have 6 plus 9i plus 8i plus 12 times I squared. All right? And that gives us 6 plus 9i plus 8i plus 12 times negative 1. Okay, once again, we're replacing this I squared with negative 1. All right? So that gives us 6 minus 12 plus 9i plus 8i. all right? And we get negative 6 plus 17i. All right, that's our final answer. All right, we're ready to move on to the division realm. All right, we're going to divide some complex numbers. All right, but before we talk about division, we need to talk about something called the complex conjugate. All right, so here's a quick definition for you. The complex conjugate of a complex number, a plus bi, is given as a minus bi. Okay, it's found by changing the sign of the imaginary part b, but the real part a is left unchanged. All right, so for example, if we have 4 plus 5i, the complex conjugate of that would be 4 minus 5i. Okay? And if we have 6 minus 2i, the complex conjugate of that would be 6 plus 2i. All right? So here are some properties of the complex conjugate. All right? When a complex number is multiplied by its complex conjugate, the result is a real number. All right? Also, when a complex number is added to its complex conjugate, the result is also a real number. All right, this first property here is the most important one. All right, this is what we're going to use to do some simplification. All right, we multiply a complex conjugate, we multiply a complex number by its complex conjugate, and we get a real number. All right, let me show you what I mean. All right, here I have 2 plus 6i times its complex conjugate, 2 minus 6i. All right, let's see what happens when we FOIL this. All right, for my firsts, I have 2 times 2. For my outers, I have 2 times negative 6i. And for my inners, I have 6i times 2. And for my lasts, I have 6i times negative 6i. All right, watch what happens to the outers and the inners when we add these up. All right, we get 4 plus negative 12i plus 12i plus negative 36 times I squared. All right, we can replace this I squared with negative 1. All right, and we can also cancel the outers and inners. Okay, that always happens when you multiply a complex number by its complex conjugate. Okay, the outers and the inners go away. All right, so we can see now that this is going to give us a real number because we have 4 plus 36. All right, and that's just 40. Okay, so this is why the complex conjugate is important. All right, it can take you from a complex number to a real number. All right, so now we're ready to divide two complex numbers. All right, here I have 2 plus 5i over 4 minus I. And I see this and I think to myself, man, I really wish that there was a real number in this denominator, because then I could split this up into two fractions and write the complex number in standard form. Right? Standard form is a plus bi. Okay? It's something plus something I. All right? So how do we get a real number in the denominator? We need to multiply the denominator by its complex conjugate. Okay? We have 4 minus I times 4 plus I in the denominator. All right? So we're multiplying this whole fraction by something equal to 1 in blue here. All right? So we're not changing the original problem. We're just shifting the format of how we look at it. All right? We're going to get a real number in the denominator. Okay? So when we FOIL the top, we get 8 plus 2i plus 20i plus 5i squared. All right? And then in the denominator, when we FOIL that, we get 16 plus 4i minus 4i minus I squared. Okay? So we can add 2i plus 20i to get 22i in the numerator. All right? And we can replace this I squared with negative 1. All right? And then in the denominator, we can see that 4i cancels with negative 4i additively. All right, so those add up to 0. Okay, and we also replace I squared with negative 1 in the denominator. All right? So that leaves us with 8 plus 22i minus 5 over 16 plus 1. Okay? So we can add these constants together to get 3, and then we still have this plus 22i, and then in the denominator we have 17. Okay? We can split this fraction into two pieces. All right? So this is basically the reverse process of getting a common denominator and adding two fractions. All right? And then 22i over 17 is the same thing as 22 over 17 times I. All right? So now we have this thing in standard form, right? It's something plus something I. So this is my final answer. All right? That's how we divide two complex numbers. All right? Let's try one more. All right? Here we have 3 plus 4i divided by 1 minus 2i. All right? I'm going to do the same thing I did before, all right? I'm going to multiply this black fraction by a blue fraction equal to 1, all right, to shift the format of how I look at it. All right, we're going to get a real number in the denominator. All right? When I FOIL the top, I get 3 plus 6i plus 4i plus 8i squared. All right? And then in the denominator, I get 1 plus 2i minus 2i minus 4i squared. All right? So we can replace the I squared up top and on the bottom with negative 1. All right? And we can cancel the outers and inners additively. All right? That always happens when you multiply by the complex conjugate. All right? Up top we have 3 plus 10i minus 8 over 1 plus 4. All right? That gives us negative 5 plus 10i over 5. All right? Once again, I can split this fraction into two pieces. All right, I get negative 5 over 5 plus 10i over 5. All right? These fractions can both be reduced. All right? Negative 5 over 5 is negative 1. All right? And 10 over 5 is 2. So we just have 2i. All right? So our final answer is negative 1 plus 2i. All right? That does it for this video. Thank you for watching, and like and subscribe.